Upon impact, a standard sewing needle, a tiny, weightless piece of metal. Now, imagine it enters our atmosphere traveling at 99.9% the speed of light. This scenario follows the rules of Einstein's theory of relativity. As an object approaches the speed of light, its mass increases, requiring a near infinite amount of energy to push it any faster. In Spanish physics literature, this is known as a bomba relativista. The needle's enormous velocity converts into a massive payload of kinetic energy, causing the tiny object to behave like a high-yield explosive rather than a physical projectile. By changing only the speed, a household tool transforms into a weapon capable of global destruction. Upon impact in Central Park, atmospheric friction creates a fireball so intense that the park and the surrounding skyline are instantly incinerated. This release of energy is 100 times more powerful than a nuclear bomb. The shock wave triggers a 7.3 magnitude earthquake, leveling buildings across the tri-state area. If the needle strikes an active volcano instead, the impact pierces the crust and releases the subterranean pressure of the magma chamber. This sudden disruption can trigger a chain of massive eruptions, launching enough ash into the atmosphere to block the sun and trigger a decade-long nuclear winter. While humans cannot produce the infinite energy needed to launch this needle, the universe naturally generates these exact forces every day. In 1991, a real-world version of this experiment occurred over Utah. An ultra-high-energy cosmic ray slammed into the atmosphere, creating a shower of secondary particles. This particle traveled at
99.9999999999999999999999999999999% the speed of light. If it raced a beam of light over 1,000,000 light years, the light beam would win by only 1.5 inches. Despite being a single subatomic proton, it arrived with the kinetic energy of a baseball thrown at 60 miles per hour. This single particle held 50 million times more energy than the Large Hadron Collider can generate. This event confirms that the universe functions as a natural particle accelerator, operating at a scale that exceeds human engineering. These extremes extend to entire stars. PSR B2224+65 is currently racing through space at 3.6 million miles per hour, creating a bow shock through interstellar gas known as the Guitar Nebula. The cosmos also challenges our assumptions about temperature. Logic suggests the coldest place in space would be the leftover background radiation from the Big Bang, but the Boomerang Nebula is colder. As a dying star sheds its gas, the material expands so rapidly that it acts like a cosmic refrigerator, dropping the temperature to -457.8 degrees Fahrenheit. By utilizing this rapid expansion, the death of a star creates a region colder than the vacuum of space itself. We often assume space is a silent void, but the cluster Abell 426 suggests otherwise. At its center, a supermassive black hole is constantly vibrating the surrounding environment. The black hole blasts high-speed jets into 50 million degree gas, pushing it outward to create visible pressure ripples. The spacing of these ripples indicates a sound wave. It is a B-flat note, vibrating 57 octaves below middle C, a frequency too low for human ears. The supposed silence of the vacuum is a limitation of our biology. On a cosmic scale, the universe is roaring. To understand why our intuition fails, consider a simpler experiment: dropping a raw steak from the International Space Station to cook it on re-entry. Atmospheric compression would heat the air molecules in front of the meat to thousands of degrees. Instead of cooking, the outside would burn into carbon flakes, while the inside remains a frozen lump. Furthermore, the steak wouldn't fall straight down. It would enter orbit, likely looping back toward the station 90 minutes later as a projectile moving at 28,000 kilometers per hour. Human intuition is calibrated for a slow, dense, and gentle Earth, leaving us blind to the violent mechanics of orbital reality. While some areas are violent, others are characterized by extreme emptiness. In a typical cosmic void, you might find only one single atom for every volume the size of a large room. In these regions, gravity is so weak that if you dropped an apple between two dwarf galaxies, it would take 50,000 years for that apple to reach the speed of a garden snail. A moment of wonder. Our existence is brief and fragile, existing in a narrow band between these incomprehensible numbers. We live in the margins of these extremes, Yet we have developed the tools to measure, name, and map the logic of a universe that was not built to accommodate us.